learning about substitution reaction and elimination reaction, it is very important to be able to compare SN1 versus SN2 in case of substitution reaction and E1 versus E2 in case of elimination reaction. So here we will start with the comparison of SN1 and SN2. So to begin with that one, we need to learn the full phrase of SN1 and SN2. As you see that in case of SN1 it should be nucleophilic substitution unimolecular, and in case of SN2 it should be nucleophilic substitution bimolecular. Now first we need to learn about the substitution reaction that involves a substitution of pairs, like two reactants will produce two products in which some things have to be switched around. Okay, for example, if you take AB as one reactant where there are two parts in that reactant, A and B, and C is another reactant, and when they react with each other they can produce AC plus B. So B in the reactant AB is replaced by C, so we get the product AC. So this is a kind of, or can be seen as an example of substitution reaction. Then we need to learn about the nucleophile. Now the reactions involved in the substitution reactions, in nucleophile which eventually replaces the leaving group, right? The nucleophiles attack the substrate and donating an electron pair to the new bond and replacing the leaving group in the substitution reaction. Now about the nucleophile, it comes from the Greek root where the nucleo, the phrase nucleo means nucleus and phile means lover. So that means the nucleophiles should be the nucleus lovers. Now we know that the nucleus are positively charged, definitely. So therefore the nucleophiles are attracted to the nucleus which is positively charged. And then the nucleophile themselves has to be negatively charged or strongly del minus. So these are characteristics of the nucleophiles. And for the substitution reactions, now we will proceed forward to see the comparison between the SN1 and SN2. Here we will check the 7 parameters and we will see how SN1 differs with SN2. These are the 7 parameters you can see: mechanism, rate equation, stereochemistry, substrate, nucleophile, leaving group, and solvent. How these parameters play a pivotal role to assign the reaction pathway whether to be SN1 or SN2. For example, we start with the mechanism. Now here in terms of mechanism, SN1 will follow 2 steps because it will form a carbocation intermediate and then the nucleophile will come and give the product. So it involves 2 steps. Whereas in case of SN2, this is a concerted process. Okay, so this is a single step reaction where the nucleophile comes from the back 180 degree, preferably with the orientation of the leaving group, and the leaving group departs, and both the thing happen simultaneously. So this is a concerted process. Next come the rate equation. As I have said that SN1 is unimolecular nucleophilic substitution reactions and SN2 is bimolecular. With the rate equation you can easily compare that for SN1 reaction there is only the substrate, the alkyl halide, which involves in the rate equation. Whereas in case of SN2 there are role of nucleophile concentration and the alkyl halide concentration. Both are important in case of SN2. Okay, then we talk about the stereochemistry. In SN1 reaction, as the carbocation intermediate is formed and the nucleophile has the option to attack the carbocation intermediate which is planar itself, and therefore it can proceed either way, and we lost the stereochemistry of the substrate. Whereas in case of SN2 we get the inversion in the stereochemistry of the substrate as we get the inverted product because the nucleophile attacks from the back end and the leaving group departs. So in case of SN2 the inversion of configuration proceeds, whereas in case of SN1 there is racemization in the product stereochemistry. Next comes the substrate. Very important this one, to select whether the reaction will proceed in SN1 or SN2, that in case of SN1, we have to check the cation stability. This is very important. For example, the benzylic cation will be preferred over allylic, then will be preferred over 3 degree, then will be 2 degree. So that means these are the sequence that SN1 reaction will proceed very well for benzylic compared to 2 degree. And for 1 degree or methyl carbocations, these are not preferable at all, because there is no extra stabilization, and without extra stabilization SN1 reaction cannot proceed, as the carbocation stability is so very important in that, because alkyl halide is the only substrate that involved in the rate equation. So the carbocation stability is very important. Comparing to the SN2, that the steady crowding plays a pivotal role here. Here you see in the first bracket or parenthesis, it's given that the methyl will be preferred over 1 degree than over 2 degree. And for 3 degree alkyl halides, the SN2 reaction eventually don't proceed. And for orbital overlap things, methyl or benzylic will have almost similar kind of, comparing to allylic and 1 degree. So in case of SN2, we will look for less crowded or less steric alkyl halide that will prefer SN2 pathway, and for SN1 we will look for more stable carbocation center which will prefer the SN1 pathway. In terms of nucleophile, for SN1, the concentration of the nucleophile or the name of the nucleophile is not very important, because it does not appear in the rate determining equation or step. So the concentration of nucleophile not that important. However, in case of SN2, this is very important because it appears in the rate equation, and preferably strong or moderate required nucleophile or nucleophilic character is very required in that reaction. There are some examples for strong nucleophiles, as you can see, this RS minus, I minus, R2N minus, R2NH, or alkoxides or cyanides, and there are moderate nucleophiles as well, like the bromide ion or carboxylate anion or RSH. Those are examples of moderate nucleophiles which can help in the SN2 reaction. In terms of leaving group, the very important part it plays in case of SN1, because better the leaving group departs, the carbocation will generate easily. So the important leaving groups, as you can see over here, that with the triplet or OTS or OMS will be preferred compared to the iodide or bromide or chloride. So the leaving group is very important in SN1, and for SN2 this is also very important for the leaving group, the character of the leaving group, because the nucleophile will attack from the backside and the C leaving group bond has to break simultaneously. So better the leaving group, it is important in irrespective of SN1 and SN2 for any substitution reaction. Leaving group role is very important, and it has to be a strong leaving group. Comparing with the solvent, for SN1 reaction, as the reaction intermediate is a carbocation center, therefore a polar protic solvent will facilitate the SN1 reaction and the reaction will proceed very fast. Whereas in case of SN2, as the reaction passes through a transition state, there is no particular development of full charged center, therefore the role of polar aprotic solvent comes into play, and in polar aprotic solvent SN2 reaction will proceed very well. So these are 7 parameters and their characteristic SN1 and SN2 outcomes, which can help you to compare between SN1 and SN2 reaction for the substitution reactions. Next we will move to the elimination reaction, E1 versus E2. We see that there are parameters. There is one parameter added, the product preference in terms of E1 and E2. The rest of the parameters are here only in case of nucleophile. Here you can see the base. So we will compare here in terms of mechanism, rate equation, stereochemistry, substrate, base, leaving group, solvent, and the product preference. Let's see. In case of mechanism, E1 reaction will proceed in 2 steps. Eventually it will follow the similar way of the SN1, that the carbocation formation will be there, and then the elimination will take place after that one, or the carbocation stabilization will take place. Whereas in E2 elimination, it is the concerted process, quite similar to that of SN2, that the base will abstract the proton or hydrogen atom and the leaving group will depart. So this is concerted process occur in a single step. In the rate equation, we will see that in E1 reaction, there is only alkyl halide concentration is there in the rate equation. That's why this is unimolecular elimination reaction. And in case of E2, it's the base instead of the nucleophile, because for the elimination it has to be the base which can abstract the protons, and nucleophiles always prefer to attack the carbon centers. Okay, so these are basic differences between the base and the nucleophile. So in elimination reaction, we have to use the base. So the base concentration is there, as you can see. So both the concentration of alkyl halide and base is important in E2 elimination reaction. In case of stereochemistry, for E1 elimination reaction, there is not much stereospecific reaction. This is because the carbocation intermediate is formed and final step of elimination proceeds thereafter. Whereas in E2 elimination, this is a stereospecific reaction. Okay. In terms of substrate, the cation stability is important, as only alkyl halide is important over here. So it follows the similar way like the SN1. The benzylic cation will be preferred over the allylic, and they will be preferred over the 3 degree and 2 degree. And in case of E2 elimination reaction, alkene stability is very important. So 3 degree will be preferred over 2 degree and over 1 degree. So this is the reverse way of E1 and E2. Next come the base. In case of E1 reaction, the base role is less important as it does not appear in the rate equation. So usually weak base can also will be preferred, or can also give the elimination product like alcohol or 2 degree amine. Whereas in case of E2 elimination, strong base is required like alkoxide or amine, R2N minus. Those are strong bases which can abstract the hydrogen atom next to the alkyl halide, the halogen group which is attached with the carbon atom, so that it can facilitate the elimination of the leaving group, and it can prepare or proceed with the alkene. Okay, so strong base is required for E2 elimination reaction. In terms of leaving group, it is very important in case of SN1 and also in case of E2 as well. As I said in the SN1 and SN2 reaction comparison before, that the leaving group is always very important, because this bond is to break by any means. So in that sense, this is very important that the leaving group is a good leaving group and departs very easily. In terms of solvent, for the elimination reaction E1, the polar protic solvent will be preferred, whereas in case of E2, the range of solvents with different polarity can participate and facilitate the reaction. In case of product preference, with the Sedgwick rule, the most highly substituted alkene usually predominates, and with the Hofmann product, we will get usually a sterically hindered base will result in the formation of least substituted alkene, and those will be called as Hofmann product. So if the product is highly substituted olefin, it will be said as the Sedgwick product. If the product is least substituted alkene, then it will be told as the Hofmann product. So these are the comparisons between E1 and E2 reactions, and hope you have understand, or you will be able to compare SN1, SN2 and E1 and E2 in a much better way after watching the video. And thank you for watching TG Chemistry. Keep watching, and please subscribe my channel TG Chemistry if you like the video, and to get more videos in future. Thank you.